Hey everybody, in this lesson we're going to talk about the physical separation of substance or matter. Because the big idea here is that we can separate substances into its individual components with certain steps. So what we talk about here is that you have mixtures. Mixtures are, if we look at the previous notes, mixtures are when you have multiple amounts of matters joined together. Or different types of matter joined together, different types of substance joined together, I mean. So you have really two types of mixtures. You have what we call homogeneous mixture, and you have what we call a heterogeneous mixture. What are the different? Homogeneous mixtures are where everything looks the same, even though it's made up of different types of substances. So it could be like, for example, a solution. And a solution is made up of two parts: a solute, which is one type of substance, and a solvent, which is another type of substance. Solute is usually a smaller amount, solvent's the bigger amount. So, for example, salt water. When you have salt water, the solute is the salt, the solvent is the water. Compare that to heterogeneous mixtures. Heterogeneous mixtures are where you can spot the difference. Like, for example, gravel. Gravel, you can tell the different types of rocks. There are also what we call suspensions, right? So suspensions, like, for example, milk spoiling. When milk spoils, it will the milky part of it will actually rise to the top, and that's because it's a suspension. So we have many ways to separate mixtures. Each one has a different reason of separating it. The easiest one for sure to separate a mixture is hand separation. Hand separation is to separate heterogeneous mixtures. And what we do is you use hands or tools to separate. So you are separating heterogeneous mixtures this way using hands or tools, such, for example, a sieve, magnets, right? So those are examples of hand separation. The next example is filtration. Filtration is usually used to separate a solid from liquid. So another type of heterogeneous mixtures. Um, it's like a sieve, like hand separation, but for finer solids. Because, for example, you can't really separate like flour from something because it's too fine. So a filter will be the what you're going to use. The next method is evaporation. Evaporation is to separate a solid from a liquid. Now, if that solid is dissolved in the liquid, if it's solid dissolved, we call this method recrystallization instead. Because when that solid will come back out of the liquid, it will recrystallize. But you, of course, if it doesn't dissolve, you can still use evaporation because that liquid will usually evaporate away. Think about, for example, water and sand. The water will evaporate over time, the sand will get left behind. The next method is called distillation. Distillation is to separate two liquids from each other using boiling point. Okay. So how does distillation work using boiling point? Here's an example. Let's say, for example, you have methanol and water. Okay, the boiling point of methanol is approximately 64 degrees Celsius. Water is 100 degrees Celsius. If you set this thing at, let's say you put this mixture in a kettle and you can control the temperature to, let's say, 80 degrees Celsius, you can boil away the methanol and you'll be left behind with the water. So that's an example of distillation. And they actually use this distillation method in a lot of different things. They use it in labs, but they also use it when they are making distilled water for medical equipment, or when they make alcohol, distilled alcohol, for example. So this is an example of a distillation compartment where what happens here is you have both liquids in here. The liquid that's going to evaporate or boil away first will be evaporated out of this tube, down this pipe, and here this thing is surrounded. This tube is cold water. So basically, there's a little thin little tube in the inside that allows the whatever is boiling away to go through, but surrounded by cold water. And that cold water is going to condense whatever you want to collect, and thus you can collect it in here. So let's say, for example, you have methanol and water. You set this Bunsen burner to about 70 degrees Celsius. Use a thermometer to track it. The methanol will evaporate, go through this condensation tube, and collect it in this flask. So you'll have methanol here, and you have water left over in here. So that's an example of distillation. The next example is solvent extraction. Solvent extraction is to separate two solids using their solubility. So what this means is, let's say for example you have sugar and sand. What we know is that sugar will dissolve when you pour water on it, but sand doesn't. So what you do is, if you want to separate sugar and sand, you will dissolve the sugar using water and then filter out the sand. So dissolve one solid and filter. But solvent extraction can be another method. It can be also to separate. So this is solvent extraction number 2 if you think of it. In this solvent extraction, it's to separate two liquids that do not mix. So what does this mean if they do not mix? If they do not mix, we call these two liquids immiscible. Miscible, on the other hand, is when they do mix. So an example of this would be oil and water. When you put oil and water together, they don't mix. And because they don't mix, they will separate based on density. Okay, so separate based on density. And because they will separate based on density, you can now use for example, what we call a separatory funnel. And for example, in this case, oil will sit on top, water will sit on the bottom. You could drain the water out first and collect just the water, and then you collect the oil afterwards. So this is an example of solvent extraction using liquids. Now there's two more different types of separation. The next one we're going to talk about is gravity separation. And this is separate by density. Because denser objects will sink. So if you ever, for example, done a blood test, they can separate the plasma from your blood using a centrifuge. So they use what we call a centrifuge. Because the denser object will sink, and thus you could collect and separate them that way. The last method is called chromatography. Chromatography. And this is to separate to solutes in a solvent. So for example, salt and water. Salt and sugar. How can you separate those two? Because you can't, for example, you go up. For salt and sugar, you can't hand separate them. You can't just pick them out with your hands or use a tool. You can't filter them because they're both pretty fine. You can't just evaporate the water and hope for the best because the salt and the sugar will still recrystallize together still. You can't use distillation. Solvent extraction will not work because they both will dissolve with water. But they might dissolve in it with a different type of liquid, for example. So what do? We have to have a different method which we call chromatography. Which means that what happens here is you're using their attraction to a stationary phase to separate. So what will happen? Well, the stationary phase can be either a silica gel or paper. And what will happen is the less attracted substance will move up a mobile phase and separate. So let's look at this one. This is an example of a chromatography of ink. Now you can also look at this on YouTube or do this on your own. But what you do is you cut up a piece of paper. Usually it is a thicker cardboard-like paper, and you put an ink spot, a black ink spot. Then you let this paper sit in some water, just a little bit of water, and through capillary action, the water will start to rise. And as the water rises, it pulls this ink spot up with it. And black ink is actually made up of multiple different colors. Now over time, as the water rises, the different types of inks that make up that black ink will separate. Because, for example, the blue ink, as you can see here, is going up with the water because it is less attracted to the stationary phase. The stationary phase is the paper, the water is the mobile phase. So the paper is, in this case, the stationary, and the water is the mobile. So the blue ink is much less attracted to the stationary phase, so it moves up with the water. The magenta, on the other hand, is a bit attracted, but still moving with the water, while the yellow is the one that is least attracted. The most attracted, I mean. It doesn't want to move the water, so it's attracted to the stationary phase, and thus you could separate out the colors. And this is chromatography. You could do this with silica gel, and so instead of it going upwards, what if you make it go downwards? So what you do is you fill this, let's say a burette with silica gel, and then you pour a liquid in, and the liquid has different solids in it. As the solid moves through the silica gel, it could be attracted to silica gel in different ways. And as it does that, it will move through it depending on how attracted it is. So the more attracted, it'll stay in the silica gel longer. The less attracted, it'll move through the silica gel a lot faster with the mobile phase. Now, if you want to check out this separation method some more, or the other separation methods, definitely check out YouTube. They have tons of great video. As always, make sure you keep yourself safe and healthy, and I'll see you soon.